Hello, this is Justin Shi, and this is the first lab assignment for EE178 at San Jose State University. In this laboratory, we will be designing a two-input XOR gate through Verilog, and to program our FPGA board. Over here, we have our design module, where we have our two inputs and we have our one output, and these two inputs are for our XOR gate, and this output would be for our this output would be our XOR gate. So for example, in 1 and in 2 it would be A and B, and our output would be Y. Over here is our test bench for our program, where we instantiate our inputs and outputs from our design module. And over here we have our test cases, where it will have our 4 test cases for our XOR gate, and which could also be seen right here, where it will test out each case, and it will see if it has the correct output, and we will be seeing this for our simulation later. Over here is our constraint file for our FPGA board, where it is programmed, where our switch 0 and switch 1 and our light in LD0 are programmed to complement our program, which we will be seeing later in our testing later. So first, we will run our behavior simulation. And over here, we see that our simulation has been loaded, and we see it right here. Let me expand this a bit better. Where our test bench was used to simulate. So as you can see here, SIG3 is our output, and SIG1 and SIG2 is our input. And as you can see here, each test case was used for example, when SIG1 and SIG2 were 0, the output was also 0. Let me put this up over here actually. Yeah, so when there it is. When SIG0 and when input 1 and input 2 were 0, the output would also be 0, as shown right here. When input 0 and input 1 were when input 1 was 0 and input 2 was 1, our output was also 1, as seen in my cursor here, and it also matches our table right here, and so on. When input 1 was 1 and input 2 was 0, it also showed up as a 1. And when both inputs were 1, it was 0. And over here it shows that our program passed all of our test cases, which means we can now run our synthesis. We'll click rerun anyways. Let me close our simulation. Alright, our synthesis has successfully been completed, which means now we can run our implementation. And while that's running, we can check our schematic right here, where it shows our two inputs and our output right here. Alright, our implementation has successfully been completed, which means now we can generate our bit stream, and this will help us to program our board. Alright, our bit stream has successfully been generated, which means now we can open our hardware manager, and this will let us select our FPGA board when we press auto connect. And it has detected our FPGA board, which means now we can program our device. And it is important to have our constraint file. It is important to locate our bitstream file. So we click program. And since we have, it seems that we have no errors, so now let's see if I can open my camera and show us our results. Let me see right here. Alright. So our constraints have programmed switch 0, switch 1, and our little light here. And let me see if I can pull up our table. So here I will show our 4 test cases. Here, our first test case is when both switches are off, which means our light will definitely not turn on. Next, I will turn on one of our switches. Let's go for switch 1 first. When switch 1 is on, we will also get our result as 1. Alright, turn that off. When we turn on switch 0 only, our light will also be on, as shown in our table right here. And when both switches are on, our light will not turn on at all. Alright, this has been the first laboratory for EE178. Thank you for watching.